So here is how you actually multiply two vectors. We call it the dot product. And it's essentially kind of like distributing, and it's really like adding. You multiply your x components together, you multiply your y components together, and then you add those two products. That's all you do for the dot product. Multiply your x's, multiply your y's, add those two numbers together. So let's look at a couple of examples here. We've got the vector 4, 5, and 2, 3. So the dot product, we multiply the x's together, plus we multiply the y's together. So we've got 8 plus 15. So the dot product here is 23. The dot product is a whole number. Okay, that is a scalar. Okay, it's not going to be another vector. It's just a number. Okay. So another one, 2, negative 1, and 1, 2. So multiply the x's plus multiply the y's. So we've got positive 2 plus negative 2. We get 0. We can have a dot product of 0. We will talk about what that means here in a minute. It actually has further implications, but that's the dot product. So go ahead and do those two practice problems real quick, and then we'll look at applying the dot product. So the dot product can be negative. Example A, the dot product is negative 6. And in example B, the dot product is also negative 6. So two different vectors there, well, 4 different vectors actually in total. But when we find the dot product, they give us the same dot product for those 4 different vectors. That is possible. Okay, any questions about just the dot product in general? Okay, let's talk about finding the angle between two vectors. Finding the angle between two vectors. There's a little formula to this, and there is a proof of why this is the way it is. I'm not going to go through the proof. I'm just going to give you the formula. We're going to use the formula. So, to find the angle between two vectors, and theta is that angle, we take the cosine of that angle, that is equal to the dot product divided by the two magnitudes multiplied by each other. So there's not a multiplication symbol there in the denominator. Technically, you can put one there because we are multiplying the magnitude of u and the magnitude of v. So let's find the angle between the vector 4, 3 and 3, 5. So let's set this up. We've got, let's see here, we're going to need the dot product. So let's go ahead and find the dot product. U times v is 4 times 3 plus 3 times 5. So that's 12 plus 15, that's 27. 27 is our dot product. We need the magnitude of both of these. So the magnitude of u is the square root of 4 squared plus 3 squared. So that's 5. 16 plus 9 is 25, square root of 25 is 5. The magnitude of v would be the square root of 3 squared plus 5 squared. So 25 plus 9 is 34. So that's the square root of 34. And we're just going to leave it like that. There's no point in simplifying it because we're just plugging it into a formula right here. All right, so the actual angle, the cosine of the angle is equal to the dot product, 27, over the product of the magnitudes. So 5 times the square root of 34. How do we find theta? inverse. Okay, anytime we're looking for the angle, we use the inverse trig. So we do the inverse trig of this 27 over 5 square roots of 34. And let's see here. Let's go with degrees. We really don't want the calculator to give us an angle in radians. We want degrees, unless the problem says radians. Now, be careful with this. In that denominator, you have 5 times the square root of 34, so you need to put parentheses around the, you got the parentheses around the 34, of course, under the square root. You need parentheses around the 5 square root of 34, and then technically there's one more parenthesis to close the whole problem. So the angle between these two vectors is approximately 22 point, we'll just round to the nearest tenth, 22.2 degrees. Now, if you really want to be thorough, I would suggest kind of sketching these vectors and see if that kind of at least makes sense. So 4, 3, let's see if I can do this close enough to scale. So 4, 3, that's my U. V is 3, 5. Okay, so that's fairly to scale. So really what we're solving for is we're looking for that angle right there in between those two vectors. 22, yeah, that looks pretty close. The main thing that I wanted to see was, you know, kind of how far apart are they? If they're fairly close, then 22 seems like a pretty reasonable conclusion. Okay, let's do another one. 2, 1, and 1, 3. So let's find the dot product. Okay, U times V, 2 times 1, plus 1 times 3. So that's 2 plus 3, that's 5. The magnitude of U, square root, x squared plus y squared. So that's the square root of 5. The magnitude of V, square root of 1 squared plus 3 squared. So that's the square root of 10. Bless you. So the cosine of our angle is the dot product, 5, over the product of the magnitudes. When you multiply 2 square roots, you multiply what's under the square roots. So I'm just going to save myself some effort right here, and I'm going to write that as the square root of 50 instead of having to write down the 2 square roots and put 2 square roots into my calculator. So again, we are of course doing the inverse cosine. 5 over the square root of 50. No extra parentheses necessary here. And look at there. It gives us exactly 45 degrees. This one is not an approximation. Our angle is 45 degrees. Again, let's give ourselves a little sketch of that and just make sure that that makes sense. Seems a little too good to be true, but could be. So there's 1, 3. The other one is 2, 1. So a little hard to tell, but I mean, it's definitely bigger than the angle that we just used. It's hard to tell whether that's exactly half of a right angle, but it looks pretty close, considering my scale is not perfect, but looks reasonable, right?